Swift 4 is the most recent. Yeah, Swift 4 is the most recent version out there right now.
When I started, it was still 3.
Yeah, which sadly they couldn't take advantage of codable types, which is it makes hitting APIs so much easier, and just in terms of like data manipulation. So codable types and file I/O. Codable. Like I said, it's something that Swift 4 introduced to make it easier to manipulate JSON data for both sending and receiving data from APIs. So you can use Codable for both when you're sending up data that you're making in your application to an external API that you might host, or if you're receiving data from another API, like a weather API or anything like that, you can basically manipulate that a lot easier using these different protocols. So the Codable, it includes 3 different protocols. So the encodable protocol, decodable protocol, and also codable protocol. We'll go over each of them individually. So encodable protocol, it basically allows you to encode information easily into the JSON representation that you specify in your class. So typically what this looks like is you have a class that you define as a codable type and all of the variables within that class. So each variable would basically be a property on that JSON object that you're making. It'll make more sense when we actually start diving into the code and actually making our own codable objects. But basically, encoding allows you to encode that object into a data package that you can then send to an API. Um, yep, so it returns back a data object. And if there's anything wrong with the codable type that you define, though, it'll throw back an error, and typically it's an issue with like mismatched property names or something like that, and that error is really helpful with what's wrong because it'll tell you exactly like what went wrong with the encoding process. So on the flip side of that, when you're receiving data, you would use this decodable protocol. So the decode is basically the reverse of encoding. You're receiving data from like an API that you're using, and you basically decode that information into that object that you define. So the parameters that you'll give is type. Type is very important. So type is basically how the decoder knows how to translate that information package into the object that you want to decode it as. And then the data is just the data that you're getting back from the API. And if everything goes well, it'll return back a value which is casted as the type that you've defined. And again, if it errors out due to some reason or another, like if the property names don't match up, it'll throw an error, and then you can sort of debug that way and catch those. So codable type. So this protocol method basically allows you to do either encoding or decoding. You have to have this on your class in order for you to be able to decode and encode something into this JSON representation of the object. And it also has to conform to the codable protocol, which we'll go over in a minute. And then input-output files. I made slides for this, but I think you guys already went over this. But you basically have a file manager, and this allows you to examine the file system on a user's device. Allows you to locate, create, copy, and move files, which you guys have probably gone over in your persistence class. And just all of these different methods. So default basically retrieves that singleton object, which is the file manager. So if you guys remember, if you ever use file manager, you don't have to basically instantiate a file manager. You basically just call it with file manager default because it's a singleton. So whenever you call file manager.default, it's accessing the same exact file manager every single time. And then document directory is basically the directory where your user's documents will live on the device. And yeah, a pending path component. All right, let's dive into code. So we'll start a new project. Oh, did anyone have any questions? It'll make a little bit more sense once I start actually showing you guys like how to implement this properly. Codable. Target. then just your standard info list. Supporting. So today we're not really going to build too much of the UI. It's going to be more of the back-end stuff so that you guys can sort of use what you've learned into your own application. So I guess the idea of what I wanted to do is go over Codable type, and I assume that most people have started their final projects, maybe? Kind of? Okay, no worries. Well, this is even better because you can start using this instead of like using the dictionary, casting it as a dictionary or thing. So, find info key list. Perfect. Okay. Yeah, no problem actually, because you can try building your service calls first and then try using this Codable type, and it'll make things a lot easier. So let's just make sure that this runs and everything. We'll hide that for now. All right, cool. No errors so far. All right, no errors. Cool. All right, so since this is just showing you guys what Codable can do, I'm gonna just do everything in the view to load for the most part. So, oops. So we're gonna start off by using open weather. Pretty easy to assign API keys. Alright, so what I typically like doing is, instead of hard coding these API keys, I'm sure you guys have to deal with this when you're using your APIs, right? I usually like storing these in a plist of some sort, so we have that info plist, right? So in here we can define a new one. There we go. So I'm just going to call this weather API key. Store that as, and then store my key in there. So this just makes it a little easier. So it makes it a little cleaner too, I guess, because you don't have to hard code this, and if it ever changes, you just change it here, and everywhere else that's using this key, you would just change it here. So let's go back into the view info, and I'm just going to write a quick private function. That'll basically get URL for weather. So weather API key. And the way you retrieve your API key, if you define it in your info key list, is basically just calling the bundle main.objects. And on this, there's a for info dictionary key. So here you would just specify that key that you define in your info key list. So I called it the weather API key. And this is case sensitive, so you have to make sure to watch out for that. And I'm just going to cast this as a string, and here I should have my key. So if we look at the weather API, open weather API. Looks like I can call something like this, and it'll return me back a JSON object that looks like this. So if you were to do this, well, we're going to go through the ugly method first. We're going to use JSON serialization to sort of get our objects and take a look at that, and then we're going to use JSON decoder to see what it saves us. So let's go ahead and define our string. So weather string is equal to, just write it out. So it's just going to be API.open weather map.org/data. Zip code. So I'm just going to search for weather based on zip code. So I'm just going to use my home, which is 6146, and that'll get us St. Louis. And then we'll pass in our app ID here, which will be what we defined up top, that weather API key. So that'll be our string, and then we'll just return weather string. And make sure that you define the type here. So were you guys using Alamo Fire or just the URL session, the iOS framework for like calling APIs? Do you remember? Perfect. Okay. Probably not. Okay. Perfect. This will All right, perfect. This makes things a lot easier. So basically, we'll go through the process of making a service call. So you have your default session, right? Which will be your URL session configuration. Session configuration. So I know you're using Alamo Fire, but you can see like just sort of low level.
I'm not dead set on it.
Okay. Yeah, absolutely. This is pretty lightweight. This is just the framework that Apple provides, and it works pretty well. Their Alamo Fire is a little bit heavy, but if you're just doing simple things like this, it's not too bad. Make a data task, and data task.cancel. Just in case there's something running right now, we'll cancel. And then if let URL components, string, and this is where we'll just call our self.url for weather. So we'll have that string set, and then URL components. Data task. There's just some safety checks, just in case the URL is invalid. So now that we have a URL, we can go ahead and do default session data task, and then we can use that URL that we have. So it'll return us back data response error. Is that kind of familiar with the, yeah. Cool. So we have that data task. And alright, let me fix some of these. Data task. Initialized. Right. That's fine. Right, there we go. Succeeded. So response. If what error, we'll just print that error. Man, that is not happy with me. That return. What's wrong? Alright, let's check. Let return data task. Response. Oh, yeah. Right. I don't know if I'm missing something about that. Oh, I'm missing a bracket somewhere. Yeah, right.
Oh, amazing.
The wonders of error messaging. Yeah, I know. I was. That's not descriptive at all. Okay.
It's like the stupid semicolons.
Oh no.
Half the time when Xcode blows up, it's
It's a missing curly. Yeah. All right. Well, now that we're past that part, we can start on actual serialization. So if you guys remember, you use the JSON serializer, right? So we'll just do two methods. So serial whether equals try JSON serialization, and then just data. So here we can just pass in our data that we get back from our response since we know that it didn't error out. Just pass in data, and then for our writing options, it'll just be empty. We don't have any options. So here we can just print out our JSON serial letter. And let's just make sure that this step up here is working. Oops. Put a breakpoint here. Wait, hold on. This is incorrect. I haven't used JSON serialization in a long time, but this is actually the JSON objects. With data, and then
Data passed or data?
data. You catch. As a test. You passed. Alright, it's gonna be optional. Alright, so now we should have our JSON serial letter. And it'll just look like your typical. Actually, we need to cast this as our dictionary. Right? So we'll cast this as a string any because we're expecting a dictionary out of this. Alright, now we're ready. There we go. Oh, Jesus Christ. I think I might have to restart my simulator. Let's see. Okay.
Yeah, it's not happening.
Moral of the story here is restart your computer. Don't wait for like 2 months or 3 months. I usually don't. I usually just close the lid. So it might get into a bad state. So yeah, do that.
Do it all the time.
It's nice because, I mean, it's so quick to start up that you don't really see any damage.
That's actually how I ruined my old computer.
Was it a Mac though? Really?
It was a MacBook Pro. My sister's like, my sister is like, I've been on for months, and I'm like, I literally turn it off every day, and like the difference in performance of our machines is like ridiculous. So, well, I think the difference between this is a new one, so it's got the solid state hard drive. My old one still has the regular disk drive in it, and if you just close it, it's still kind of running, and if you bang it
Right.
against anything, it makes it skip. And ruins the
Oh my
hard
gosh,
drive.
that's terrifying. All right, so important note here is, are you guys familiar with this error right here? So app transport security has blocked a clear text HTTP resource. I don't know if you ran into that issue when you were working with any APIs. Okay, so this issue right here is, man, you can, yeah. What is that something that
Wouldn't
Yeah.
be a security, an app, app, starts with a T.
App
something.
security, transport security settings?
Yeah.
Look at that. Okay.
And then you have to turn it to yes. Because it's a
Okay.
Boolean.
Yeah. Well, we have to add something. Come on.
Oh,
There's a little drop down.
yeah, it's tricky.
Oh, there's nothing there.
There we
you
go.
Allow
Okay, so
arbitrary
you have to do the drop down first.
to do the
You
arbitrary.
know, Apple just doesn't make sense sometimes. I expect that if you click the plus on a, it would, yeah, it would
So it just
automatically.
adds a new item, but if the drop down's down, it says, oh, add a new side.
Yeah.
That's a hangover from a Ripley C, though.
Someone was hungover when they did this. Yes.
That's not what I said.
Oh.
God damn. That person's doing their job, right?
Yeah.
Like, I'm going to work for Apple,
Good
but I can
point.
work while
I
hungover.
wish I could be hungover.
Yeah,
I
seriously.
mean, I guess you can if you really want to be. But
You gotta do you.
you shouldn't.
Yeah. Internet's so good. There's something wrong with it. Alright, let me work some magic and look at what I did last night when I was in this class. It's reading and writing. I must have just misspelled something. Let's make sure that that's the issue. Right. That looks exactly the same to me.
One of your letters
Was it not? You'd be right, because it works now. So, make sure you type in your URL correctly. So, right here we have this giant weather object, right? So, with the old way of doing it, you would have a dictionary, and it would be a little harder to manipulate because each property might have an object under it. So, it would be like string any, string any. It would just be cascading string any's, and you have to basically get rid of the optionals when you're trying to access those variables. So with Swift 4, though, to my point with the JSON decoder, we can make this process a lot easier by defining objects that will define our weather information. So we'll go ahead and do that now. Stop this madness. And breakpoints. So we can easily do this by creating a new file, which will be our codable type for weather. So next, weather. So we have our new weather class, define class, weather, and this is the most important step. You have to make sure to define this as a codable type. So now we can look at our objects. So we'll just do name first, and then after that we can start filling in the other things. So var name is going to be a string. So now we have a weather object that has one property, which is name. We'll test this first just to make sure it works. So if you have missing properties, it just won't fill those in. So that weather object that we're getting back, it has a lot more properties than what I define in my Codable class, but it'll just go through and find what it can find. So it'll find name and populate that. Hopefully, fingers crossed. So here, we'll just do we'll have to do, so we'll do a do. So do JSON decoder weather. We'll go ahead and try. So we don't have to put a question mark here because we're encapsulating it in a do block, which will throw an error if there is an error. So all you have to do is, instead of using this JSON serialization, you're going to use JSON decoder. And you have to instantiate it, and then you'll do a decode. So these are the two parameters of JSON decoder. You'll have a type, which is that new thing that you made, right? So weather.self. So it'll try to cast it as weather. And then data is just the data that we are getting back from the service call. So now, if everything went well, it'll get past this line. So now we'll have JSON decoder weather. And all we'll do is just JSON decoder weather and see what that looks like. I am missing a catch. This is nice too because sometimes if you don't have this cache, you won't know what's wrong with your JSON decoder, and it'll be really, really hard to debug, if not impossible. So, right, it's just an NS error type. So, um, it's just a type of error that you can cache your error as. Just do that. Fine. So I'm going to put a breakpoint right here just so that we can dive into this object that we'll make. Alright, so we print out that response up ahead, and here is our JSON decoder weather. So it's an actual Swift object that you can use. So here, that's our name, or that's the name of the weather information that we get. So past this, you can actually use it like an object. So you can use JSON decoder.name and all the other properties. So I'm just going to go ahead and fill in our weather class a little bit more. So we have name. We probably want some other attributes, right? So weather gives us name, ID, probably doesn't matter. So the next case is, what if I have an object in an object? So something like main, right? Main has my temperature, pressure, humidity, temp min, temp max. So if you use JSON serialization, that would just be another string any within your string any. If you use Codable types, it's actually a lot easier to manipulate. You would basically just define a new class. So we'll define a new class as main. You'll define this as Codable too. And you'll just start filling in the properties. So we have var temp. Now this is actually pretty important. So those names that you define in your class, they have to exactly match up with the names that are coming back from the service. Otherwise, it won't know how to cast it. There is a way around that though, which I'll go over after this thing. So we'll have a double pressure, which is int var humidity, which is int var temp underscore min. So typically things that APIs will return things in camel case, or not camel case, snake case. And you might just want to use camel case in your app. You can define it yourself. Here in a second. Let me finish this real quick. Max double. Right. So now we know that main is going to be coming back in our initial weather object, so we can define main here. And instead of casting it as a string any, we can cast it to this Codable type that we just made. So that way we get like nested objects, which is really nice. And if we run this and break where we were, so broke here, you'll notice that we have two things in our object now. And if we open up main, this is all of the information that's coming back from that call, which is really nice because you don't have to worry about optionals or finding keys in a dictionary. You can just manipulate this weather object that you made. So suppose you wanted to maybe make these camel case, and you would define something called coding keys. So coding keys basically allow you to define your own custom. So with the return data that you retrieve, you can define custom keys for these objects. So say you want this, instead of snake case, to be camel case, you can do that. But you have to make sure to define your coding keys, which are just an enum of coding keys, string, and coding keys. And here you would define each case. The thing with this though is if you define coding keys, you have to define one for every single property. So even though I'm not changing temperature, pressure, or humidity, I have to add cases for those. I don't have to fill in the cases, I just need to have them there. So case pressure, case humidity, and this is where it's a little different, right? So these are snake case because that's what the API is returning. And this is where I would, well, actually, equal to temp min, and then case temp max, temp max. So that's temp. I'll just do this for shits and giggles, but I'll name this temperature, and then define a coding key for this guy too.
The other way.
Yep. Temp.
Can I get pick spell?
Yeah. Did I spell it wrong? Yes, I did. It's E.
Temper
Temper. I'm spelling a lot of things lately.
is phonetic spelling.
Yeah.
Lord whispers.
I'm missing a. Okay. I think I'm missing something small. Singular. Small things. Alright, cool. So if you were to just implement the ones that you wanted to change, it would throw off this error which says you have no initializer because you don't have any initializer for these guys. So if you are wanting to change a key, just make sure that you change it for, you may have a case for every single one of them. Alright, cool. So, let's go ahead and do this. Is that kind of making sense so far? Do you guys have any questions? Does that look like it might be easier to use than the dictionaries? So here we have our object now, but you'll notice one big difference is that these are camel case now, and then temperature is temperature. So suppose you didn't do that on accident. Say you maybe you just forgot, or maybe you misspelled something. This is what would happen. So let's just do that. So you'll get back this terrifying error that says no value associated with key temperature. So if you didn't have that error catching though, you would just, the app would just crash and it wouldn't throw anything back. So make sure if you ever use Codable, wrap it in a do catch so that you can get this error back, just in case like some API keys change for whatever reason and your app just crashes out of nowhere. This will be really helpful. So I'll put that back. And I'm going to get my charger real quick. Which I remember to bring this time. Which is
I
good.
remember to bring mine too.
I also brought one.
Perfect. Appreciate it. Appreciate the backup chargers. All right. So does that kind of make sense? Do you guys like it better or worse than dictionaries? Better? Yeah.
Better.
Much
It's gonna
better.
be easier. It looks cleaner too.
Yeah, it's definitely a lot cleaner, and where we print, you can just use JSON decoder weather, and you have everything in your weather object. So if I want to look at temperature, I just do main.temperature, and it's right there. So I don't have to decode it, or I don't have to search through keys and figure out any of those things. It's a lot easier. So the next part is file I/O. I'll leave it up to you guys since you guys have already done like persistence-based stuff. But you can also use JSON decoder to save things as well. Instead of having to cast it to a string any, you can use JSON decoder to encode. So I have something small that we can go through, unless you guys feel like you're experts at persistence. All right, let's go through it again. No worries. So-
it helps her.
Yeah, absolutely. So now that we have our JSON decoder weather, this is completely redundant, but I'll just show you what you can do. So we'll let write JSON decoder weather equal to JSON decoder weather dot. Actually, just try decoder JSON encoder dot encode. Right. So here we'll pass in our object.
Okay, but encoding is you writing to the API, the
Right.
database, right?
Yeah. Actually.
Can you write to somebody else's API?
Oh no. So
Okay.
I'm gonna. Sorry. I'm not gonna be writing to their API. What I'm gonna be showing off is basically encoding data objects
Okay.
and then saving that as a file on the device.
Okay.
So no sending to the APIs, but if you had an API that you wanted to send to, this would be the same exact route.
Okay.
Let me. Okay. That was fairly easy. So encoding is decently easy. All you need to do is pass in your objects, and you should have. This will return a data package that you can then save. So let's just make sure that that works. Okay. Cool. All right, so it encoded successfully. Otherwise, it wouldn't have gotten here. But since do you guys want to do more of an exercise, like show me how, like tell me how to write this to a file? Would that be more beneficial for you rather than me just like telling you how to do it? So just like the first steps of how do I have this data package right now, right? So what are the steps that I need to do to basically write this to my documents directory? What is my first step? So right, exactly. That is a good first step. Where is
This
that?
is all up to you because we did not learn this.
Oh yes. Oh yeah. I guess we didn't go over. Oh, yeah. Sure. Well, I mean, first thing is maybe we should write a function for this rather than just sticking it there. So private func write data file name, and then we also have a file extension probably. Does this sort of look familiar-ish? Sure, like I don't even know. Like I don't know anything about file like persistence,
Nope.
and you're teaching me. I guess this is more gonna fall on you because we didn't teach you guys.
Yeah.
So
Nope.
I guess. I don't know,
Other
what do
than
I do? I have no idea. Right. So you brought up a good point in the beginning, right? You have to get the document directory that we want to write it to, right?
So, and you said earlier that file manager is
Right. So how do I use it? Just file manager. Yep. By default. URLs for version size. So here we have a search path directory and search path domain mask. What are my search paths? If I just want to save it to a document directory for the user. So if we go back to, oops, sorry. So these are all of my options, right? It's a little overwhelming. There's like a million different paths that I can save it to. The one specifically that we want to deal with is, I don't know if I had it in my slides. Document directory, right? So document directory refers to the user's document directory. So if we go ahead and just fill this in, is that what you have? document directory. So if you're ever confused about which directory you should save things in, you can always command click into here, and it'll give you no information about any of this. Just so yeah, you're kind of on your own. On that one. Oh yeah, I guess their documentation isn't that filled in for those directories. It's probably on their website somewhere. And then here, I think I was thinking about this one. So you want to use user domain mask, right? And this here, you'll actually get some comments of like what each of them are. So that's kind of useful. They don't have anything for the directory side, but yeah. So we have our document directory now. What do I do after that? Now that I have it. Probably want to create my file path, right? What the name of the file and where it's going to live. So file URL to document directory. Oops. Yep. Dot. Wait. This returns back an array, so you just have to make sure we get the first one in that array. So now that we have our document directory, we can append path component. So this is where you start building off of that document directory that you have. So we're just going to do, so we pass in data, file name, and file extension. So we'll just start building our string here. So first thing is probably going to be our file name, not file name. And then next after that, we'll probably do dot, and then our file extension. Cool. So that's pretty much all we need to define for our file URL. Basically, just a file name and then the file extension. And after that, we can just do file data. Data. Really?
Hey, it's document directory. Document
That's it?
directory.
Oh, that's helpful.
Hey, it's documentation directory.
Perfect. So yeah, just remember to use this one. This is probably for 90% of your use cases going to be in the document directory. My computer is a little struggling, so I'm not getting autocomplete. But does that look good? That's pretty much all I need to write. Right. You're right.
Yay! She passed the pop quiz.
Yeah, what was
Writing.
That's not the purpose of this function, even though. All right, so we have all these things now. Man, what was I looking at?
Skip what we missed a few lines.
Yeah, I definitely just started reading off the read part. So, all right, good catch, Courtney. You passed. All right,
Still
so
have to do your fun stuff.
anyways, though, yeah, still have to do your final project.
Dang it.
But how do I write?
So then we have the wherever our data is, we can do that dot write to the file URL.
Nice. Seems pretty easy. There's a save. Well, I guess you have to try that. So this is probably going to complain at you, though. I hope. Right. So errors thrown from here are not handled. So every single time you do a try, you always have to do a do. And just stick that guy in there. And catch let error as, yeah, just be an NSA. We just print it for now. But yeah, that's our write, right? Cool. Alright, now that we have that finished, we can go back to this guy. So if you remember back from the slides, that's encodable will return you back a data object as long as it can encode it. So go back here and then just do our write. So self.write data. So this will just be our write JSON data then. And file name, let's just do JSON decoder.name. Alright, so wait, let me do something before I do that. I'm going to go ahead and print out my document directory just so I can go ahead and access that through Explorer. Alright, cool. Does that all make sense? You actually have to write in your right too, remember? Alright, cool. So spit out this guy. It's going to go ahead and open. You can tell that I've been doing this a lot. So wrote successfully. If we open this back up, this will be blank page. There we go. Alright, cool. So this is all we wrote, right? So we retrieved from a weather API, we got a bunch of data, and we have two things on our weather objects that's a codable type, and we successfully wrote it. So we basically pulled from an API, got name and main out of it, and then wrote it to a file on our file system. And the reverse, so it's a little redundant what we did since we like pulled from an API, converted to a weather object, and then wrote that weather object. We could have just written that data package directly to our file system. But this was just to more show you guys like what you can do with codable types. So what we can do now is we can read from it. So writing is just as important as reading. And can you show me how to read from a file? Perfect. File extension string equals to JSON. Just a reverse, right? So we'll do let document directory.
Oh, you get it from.
Same thing, right? You get a document directory and then you build that file URL. So yep. Look at you, master. You didn't even need this.
Wow.
It's a good refresher, I hope.
Yes, it is.
Where's my data constructor? Oh, here we go. Okay. Contents of file URL. Alright, cool. Oh, we should probably return it. Data. Alright, cool. So now we have a. I'm missing it back. Oh, right. Right. Because I define it as an optional data package. Okay. So that should build. And if we go back to this, go back to our right. So this we've read from the API. We've casted it to we've decoded it to a weather object. We've encoded it back to data. We've written data, and now let's just read in what we wrote. So read in file name. It'll be just JSON decoder.name. file extension. Specify that guy. So this will return me back data. So let read in JSON data equal to that guy, and then in JSON data. All right. So quiz. How do I decode this back to my weather objects? Yep. So try JSON decoder, and just remember that you instantiate it. If you just do JSON decoder, it'll give you this, and it doesn't really make much sense. So make sure you instantiate it, and then do a dot decode. And this will just be our weather type again, right? So weather.self, and then our data will be our read in JSON data. So read in weather equal to that. Print read in weather. Put a breakpoint here. Alright, so that's our JSON decode weather. See our read in weather. And you'll notice that it's the same exact thing that we wrote in. Cool. Full circle. So read, write, JSON decode, encode. Does all of that sort of make more sense now? A little bit cleaner way of interacting with an API and saving files using an encoder, decoder, instead of having to build dictionary objects and writing those. So yeah, that's pretty much all I had for today. If you guys had any questions on this, hopefully this will help you with your project too. Are you using Swift 4?
Yes.
Perfect. Well, you can fully utilize all these codable objects. And this is a lot easier to work with than dictionaries. But yeah, so
So okay? An API is basically a database that you're going and pulling from somebody else.
not necessarily. It might have a database that it interacts with, but an API is basically a service that provides you with a certain set of data.
Okay, so if I have my own database,
Right. You have to build a service layer on top of that, and that would be the API.
which I did,
Right.
but then do I have to create multiple services to write to and get data from, or should that be all in
It
one
should
service?
it should be one service, but in that service you can have multiple endpoints, I guess. Does that kind of make sense? So you might have multiple gets depending on what you're trying to get out of the data. But it typically is one service. You could potentially write multiple services for it, but I think in your case you probably just need that one service with multiple endpoints. So, yeah, absolutely. So that wraps up the lecture that I wanted to give you guys. Hopefully you got something out of it.